Okay. A digital music service offers 2 subscription plans. We're going to compare these 2 plans. Plan 1, the first plan, and we're going to compare it with the second plan. Okay, first versus the second plan. The first plan, they charge a $9 flat fee. It's a one-time fee. And now every time you download a song, they charge $1 for every download. So if you had 1 download, it's 9 plus 1. If you have 2 downloads, it's 9 plus 2, and so forth. So we need a variable. Where would we put the variable? Right next to the 1. So D is the number of downloads. Now the second plan charges $25. It's a little larger than the first plan, but then they only charge 50 cents for a download. Okay, so these are the 2 expressions for each plan. They want to know how many downloads, how many songs must you download so that the second plan, plan 2, is going to be less than the first plan. So that's what inequality sign we want. We want this to be less than that. So now your job is to solve this. Remember what D represents. D is the number of downloads. So how will we solve this? We're going to subtract 0.50 and then subtract 9 on the other side. How many downloads are you going to get?
34.
I got 32 when you do the math. So subtract, you're going to get you should have gotten 0.5 if you want to find any errors. 0.5D is greater than 16, and divide by 0.5. So let's graph this answer. So 32 is our critical number. We want to say more than 32 downloads. Anything more than 32, but not 32. At 32, both plans would be equal to each other. So if I downloaded 32 songs, it wouldn't matter which plan I went with. Go with the plan that, go with the company that is more reputable. Okay? But if I'm a download person where I don't download everything, like 100 songs every month, you're going to want to go with this plan because it's less for each download. But if you only download 30 songs, it's cheaper to do the first plan. Does that make sense? I hope this is a real world example. For homework, I want you to play around with 24 and 25 on your own. I'm not going to tell you every single one of these. We're going to go over these on Monday. So have the packet completely done and I'm going to fly through. Homework is important because that'll gauge your understanding if you need some help. If you're getting a lot of problems wrong in a section, if we can't correct those mistakes before you take your test is going to be a disaster. So what do you do in this problem? Okay, distribute. 8x, what else? You tell me. Minus 12. Less than? Okay, now what? Subtract 8x. Well, when I subtract 8x, that's what I get. So I've got this thing. Negative 12 is less than 8.
True.
Is that a true statement?
Yeah.
Is it always true?
Yeah.
Is it sometimes true? No, it's always true. Okay? So ask yourself, did I answer the question that they asked me? It said, is this problem always, sometimes, or never true? Did we answer it? Yes. Now, what if I would have said, what is the solution to this problem? If I asked you what's the solution, you would say infinite solutions. Now, these questions are completely different. You guys need to learn at this point, you have to read the question and answer it. And I use this analogy all the time, you're gonna get sick of it. If I ask you a question, if I say, everybody, tell me what your favorite color is, and you say pizza, did you answer my question? No. So, with that being said, I get this answer all the time. I'll ask a question. Is this sometimes, always, or never true? And people will write, they'll do this, and then they'll write infinite solutions. This is a correct answer for a different question. The question is this sometimes or never true? Or always? And it's always. Now if I said, what's the solution, and you wrote always, that is incorrect also. Even though I know what you're talking about, but you're not answering my question. When I say, what's your favorite color, and you say pizza, I know what you mean. You mean your favorite food is pizza. You didn't answer my question, but you did tell me something about yourself. So do you guys understand that? You need to read the question and answer it correctly. This means what numbers you would put in for X that would make it work. That's the answer to solving it. But that's not what they asked, okay? So you play around with these two, and remember, answer what they ask you. All right, the next review thing is compound inequalities. Compound. See this word, and. It's important, okay? But hold on to it. How do you do this problem right here? The 8 less than or equal to 3x minus 1. How do you do it? Add 1. Divide by 3. Now, to me, this is a math sentence, but it's backwards. What do? We rewrite it, flip it. Okay? And now let's do this side. Divide by 2, and you get x is less than 6. All right, now let's take a look at this first half. This first half is saying all of the numbers, including 3 and bigger, are a solution. These are all the numbers that work for this half of the problem. So from 3, including 3, to infinity, every number will fit this problem. Now this one right here, what's the solution? I'm graphing it over on this side. I'm going to put a 6 here, and I'm going to shade right on this side. Now, these numbers satisfy this half. What an and, the word and, is a conjunction. It is asking you, I want the answer where it fits both of these problems. What numbers fit both? The numbers between 3 and 6, but not including 6. From 3 to 6. So you're looking for that region right there, the overlap. So some people do them separate, and some people can just do it all in one shot. It's like me saying, the word and means I want pizza and Chinese food. I want to eat pizza and Chinese food. Can I go to Andiamo's for dinner? Not unless they started serving egg rolls, okay? Or fried rice, which they don't. The word and means I want a place where it serves both. I want both of those items. So this is the region right here. Right here.
Okay.
Thanks. So the answer, if you graph it, it looks like this. 3 here and a 6 here. This is the region. This is the graph of the solution. So an and is the overlap, the intersection of both problems. An or is a little different, and you're gonna do those two for homework, obviously. An or, if I said I want Chinese food or Italian food, that means one or the other. If the restaurant serves one, I'm okay with it. But the and one, I'd have to go to like a Golden Corral where they serve all kinds of goofy things, and you can just eat whatever, pick out what you want. Do you ever have a craving for different kinds of foods? Do you ever eat like you have a craving for something and you start eating like pickles and ice cream and and then you eat cereal, and then I eat a bowl of cereal, like that kind of thing.
No.
An or is just
Mine usually is a donut.
you put them both on the same, and if it's on there, if it's on the number line, it's a solution. So what do you do in this problem? You do them separately. So 7W is greater than 8. Divide by 7. W is greater than 8/7. Now the other side, you're going to add 1. 4W is less than -12. Now I have a question. I have a question for you. What do I do next? Should I flip the sign? Yes? Should I flip the
Oh,
sign?
no, because I divide by negative,
Ah,
divide by negative.
okay. Did everybody catch that? When do you flip the inequality sign? But there's a negative.
You're not done.
Yeah, divided by negative.
Oh, okay. Does everybody understand that? Because someone asked that last in 4th hour. They said, how come I didn't flip the sign? And I want to make sure if anyone has that question, I address it. Everybody's cool? You don't flip the sign if this is negative, you flip it if the 4 is negative. Everyone got that? All right, now, how do we graph this inequality? Well, I want all the numbers. Anything that fits any of these two. Well, where is what's the smaller number? 8/7 or -3? What number should I put first on my number line? You better be able, because I have seen this. I've seen it where, yes, you got 8/7. Just because you got 8/7 first before this side, I saw people do this. This is incorrect. What's wrong with this? On a number line, is that correct?
No.
No, that is the correct, you have to be able to order numbers. So please, make sure your numbers are in the correct order on a number line. And now graph, where are the numbers less than 3? Okay, there they are. And where are the numbers greater than 8/7? Okay, there they are. Now typically, but it's not always. Typically an and looks like, did you ever hear of the sandwich? It's a numbers in between two. And then typically, an or, they look like they're going in opposite directions, but not always. I'm not gonna tell you, so don't think that every or, the arrows are both shaded on opposite ends, and don't think that an and. Sometimes an and can be no solution. Sometimes an or, if I give you this problem, if I said x is greater than 3 or x is greater than, you might get something like this. If x is greater than 3, it looks like this, right? And if x is greater than 5, it looks like this, okay? So what would be the solution to this or? It would be from here on. The actual answer would be from 3 on, right? So that doesn't look like arrows going on both ends, so you gotta watch. What if I change this to an and? What would be the solution? Where are these two overlapping? From not 3 to 5,
5
5 and up. An and now means what region are they both shaded, and that would be from here out. So if it were an and, you would have a 5 like that. So watch, there's some cases, and then what if I did this? What if I said x is less than 3 and x is greater than 5? Where's the solution?
But no, there isn't.
There isn't one. Good job. Because this one this one would have a 3 going that way. This one has a 5 going this way. What region do these two have in common? There is no solution on this one. So you gotta understand at this point what an and an or is. Yeah.
With that, with the and, when you change that one problem to an and problem, you did the 5 and up, would you only put the 5 or do you have to include the 3 as well?
No. Wait, say it again?
Like, 'cause
Okay,
you know
so
how up
this
there
one
in the
right
right
here.
corner, yeah, in the right corner here, you have put the 5 and up, because that's where they're both shaded
Right.
together.
Yeah.
Do you only put the 5 or do you also list the 3 just to know it's there?
No, because it only goes from an and, it would be from this region on. And you're not including the 5 because the 5 has a parenthesis here. So this is the region. This is the only region that is both this and that. This is this region here. So in other words, numbers like 6. 6 is bigger than 5 and 6 is bigger than 3. So these are all the numbers that satisfy both. Does that make sense? Not this. This is not part of the and. That would not work. None of that. Okay, good questions, guys. All right. So, for homework, you guys are going to finish this packet, and I will answer your questions on Monday, but we're not done. We are not done. No, no, no. Absolute value stuff. Do you guys remember absolute value? What does absolute value mean?
The numbers, how many numbers you are from 0?
The distance or how many units you are from 0. Can you guys just grab one, pass them along? Grab one, pass them along. If there's any extra, just leave them on the floor and I'll grab them. Okay, so this is a review, real quick review of absolute value. Absolute value is yes,
You can give her a row, Kenny.
they're circulating.
Oh, okay.
They're circulating. Absolute value is how far a number is from 0. That's what those bars mean. This should be review. So if I asked you, look at question 2. Let's fly through these. Everybody have one? What's the absolute value of 3? In other words, this question without words says, where's 3? It's 3. Here's 3. How many units is 3 from 0?
3.
It's 3 units. Okay, where's negative 2? Here's negative 2. How many units is negative 2 away from 0?
2.
Okay, this one is saying 1. How many units is 1 away from 0? 1, but then they want you to multiply that number by negative 1. Everyone got that? And then the last one, number 5. What's the absolute value of negative 2?
2.
And then take that number and multiply it. Okay, good? Okay, next, check this out. I have a question for you. What could x be so that if I took the absolute value of it, I would be 4 units away from 0?
Plus 1.
Go ahead. You're gonna tell me?
sorry.
No, him.
4
4 and negative 4, excellent. Right here and here. Why 4 and negative 4? Because negative 4 is 4 units away and 4 is 4 units away. Good job. How about, so you could write plus or minus 4 for an answer. X can be a 4 or a negative 4. How about this next one right here? What would it be?
Plus or minus 5.
Good job, plus or minus 5. Now I have a question for you. Look at this one. What would x have to be? Give me-
It's not
It's not a
possible.
number, because you can have a negative.
You can't have it unless you multiply.
Ah, You guys are smart. So what's the answer?
Indefinite.
No
Undefined.
solution. You guys are smart. Okay, so, good thinking. You can't take the absolute value of any number in the world. If you could, and it come out to be a negative, I'll give you my house. If anyone can make it work, it won't work. It is not possible. Now, can this number be a 0? Yeah, you can take the absolute value of 0 and it's 0. But there's no number that you can take the absolute value and get a negative number. It just doesn't work. Fourth hour struggled with that. It took me like 15 minutes to get them to understand this. You guys right off the bat got it. So, okay, so everyone's got that. Now, so basically what you're going to do is you're going to make sure that this number is a positive number. And then you're going to break it up into two problems. You're going to say, to drop the bars, you're going to say 3x plus 2, it can be a positive 4, or 3x plus 2, and we're going to write the negative 4. And we're going to solve each one of these, right? So the word in between is or, because there's two different answers for this one. On the left side, if we subtract 2, 3x equals negative 6, x is negative 2. Subtract 2, 3x equals 2, and x is 2/3. Now, why do we get two answers? Because they both work. Watch this. If I plugged a negative 2 here, can you guys do this in your head? This is our little check. What is 3 times negative 2? What's negative 6 plus 2? What's the absolute value of negative 4? It worked. It worked. How about this one, 2/3? What is 3 times 2/3? It's 2. And what's 2 plus 2? And what's the absolute value of 4? It worked. Now they're asking you graph the solution. All that the graph looks like are 2 dots. So what's smaller? Negative 2 is smaller. Just put a dot. And 2/3, put a dot. Done. You guys good? Okay. Flip. Next page. Check out this one. Anyone have an idea what we should do? Should we distribute the 2? Should we? No. It's not a parentheses. Good job. But do we just break this up? Before you break it up, make sure the absolute value is alone. Is it alone? Got some company here. How do I get rid of these two pieces? Should you divide by 2 first? I would get rid of this first. Subtract 3. And then do your multiplication and division at the end. Right? Now at this point, just do a little quick check. Make sure, before you break this up into the 2, make sure it's a positive number. Everybody okay with that? Now, what 2 problems are you going to make this?
X plus 9 equals negative, positive 2, and x plus 1 equals 9.
And go ahead, what are your 2 answers? You got it. Negative 11 and negative 7. And they both work. Okay? So you can do the next 3 for homework. And then what about this one? What do you do here? Bless you. Thank you. Anyone? Okay, we're gonna break this up into, we didn't do a lot of these in Algebra 1, but we did do them. Here's one problem. What did I do? Just wrote it down without the bar. And the other one, now, we made one a positive, one a negative. You're doing the same thing. But unfortunately, there's 2 items here. So we have to take the opposite of both of these. So if you wanna just write negative 7x minus 14, you could just put a negative in front of both of these and that's fine. Now solve them. Add 7x, you get 12x. Add 2, you get negative 12. So x is negative 1. I did it fast. Next one, subtract 5x, you get 2x. Subtract 16, you get negative 8. Good? Now, what you want to do is you want to check for extraneous solutions. The reason you might have a false answer, one of these two might not work, or both of them might not work, is because you have a variable here on this side. And only these problems, you're going to have to really check to make sure that some of these answers are not false. Let's check. If I put a negative 1 right here, what is 5 times negative 1? Negative 5. What's negative 5 minus 2? Negative 7. What's the abs of A negative 7? 7. Okay, we got a 7 on that side. How about this side? What's 7 times negative 1? Negative 7. What's negative 7 plus 14? Does 7 equal 7? Okay, so this one's good. This one works. It's a good answer. Okay, how about this one? All right, let's use common sense here. Whatever number I put in here and evaluate it, what's it going to come out, positive or negative?
Positive.
It's going to be a positive, right? When you take the absolute value of anything, it's going to come out positive. But I already know, just looking at this problem, put a negative 8 right here. What kind of number is going to come out here? A negative. So I already know this is not going to work. This is extraneous. This one is not a good answer. Because, and do the math if you don't believe me, but if you want to check quickly, a negative 8 times 7 is a large negative number, negative 56. When I add this number, it's going to come out negative, and I know the absolute value of anything is positive. So I'm going to get a positive equals a negative, and it's not, I know it's not going to work. You get that? Okay, cool. Next, flip it over. Do you remember absolute values with inequalities? This is a less than problem. You guys remember if it's an and or an or. So like for example, if I said this. What numbers could I take the absolute value of that would be less than or equal to 3? If I looked at a number line.
3 and under.
It would be 3. Okay, so you agree that any number that's a 3 and under. What about, what if I put a 4?
No.
Absolute value of 4 is 4. Is 4 less than 3? No. What about some of these negative numbers, like negative 1? If I put a negative 1 here, what's the absolute value of negative 1? 1. How about 2?
2.
Would 2 work? Negative 2 work? Mm-hmm. How about negative 3? Yeah, negative 3 is absolute value is less than or equal to 3. So with a less than, it's an and problem. It's the sandwich one, the one in between. So this is what you're going to do. With a less than is an and. You're going to do this. You're going to write 3x minus 4 is less than or equal to 8, and it's greater than, we're flipping the sign, but we're going to write it all in one shot. You guys remember doing these now? Yeah, it's coming back. All right, what do you do now? Add 4, add 4, add 4. So you get 3x is less than or equal to 12. Divide by 3, divide by 3, divide by 3. So negative 4/3 is less than or equal to x, less than or equal to 4. So in other words, the solution, like this one, the solution was everything between negative 3 and 3. This one, the solution is everything in between, all the numbers between and including negative 4/3 and 4. These are all the solutions to this. Questions? So all of these are ands in this set, less than, and you want to get rid of this 4, subtract 4. You want to get rid of this 3, subtract 3, but then you're going to do it exactly like we did here. So practice those. Now, for this one, this is an OR problem. Greater is an OR. It's like if I gave you this problem, absolute value of x is greater than 3. What numbers could I put in here? Think of a number line. 1, 2, 3. Give me some numbers that if I plugged in for x and I took the absolute value of them, it would be a bigger number than 3. Like, would 0 work?
No.
No. Would 1 work?
No.
2?
No.
No. 3?
No.
3 would be no, but would 4?
Yeah.
Yeah. So I know this region, but what should I do with the 3? I'm gonna put a parenthesis here. So it's not, now if I had a bar here, I would have a bracket, right? So I could include 3 if I did a bracket. Now, are those the only numbers that if I took the absolute value would be bigger than 3?
No.
No, it's this side too. These numbers work too. Because if I took the absolute value of -4, I get 4, and 4 is bigger than 3. So an OR, a greater, it looks like they're on opposite ends. They're shooting out opposite sides. So how do you do this one if it's a greater? You're going to break this up into 5x plus 10 is greater than 15, or, and then I go the other way, I put the negative number, 5x plus 10 is less than -15. So I want to flip the sign and make them, I like to make it look like exactly like these, typically how these graphs look. And now do each separate problem. So subtract 10, 5x is less than -25, divide by 5, and you get x is less than -5. Or subtract 10, 5x is greater than 5, x is greater than 1. So this is the answer. And what does my graph look like? At -5, you're going to have a parenthesis and shade all these numbers. And at 1, you're going to have a parenthesis and you're going to shade all those. Questions? So these 3 are ORs at the bottom. You're going to practice those. Okay, now let's look at this. Okay, these are 2 closed circles right here. Okay, can you write these 2 inequalities for me? X is less than -5, or x is greater than 1. Does everybody agree that that's what I see on that, you see on that graph, right? This is an OR. They're out in opposite directions, right? Okay, we're going to follow these steps and then I'm going to have you figure out how to do these. Can you tell me the halfway number between the, we're going to actually write a compound inequality for this problem. Where is the halfway number? If in between these 2 critical values? -2. -2 is the halfway number. You are going to take the halfway number and you're going to subtract the halfway number. Always subtract. You're going to subtract the halfway number from here, 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 and here. But what's another way of subtracting a negative number in this case?
Adding.
Adding. So does everybody agree that this is really adding 2? You subtract a negative, you're really adding 2. So do you know that these are the same thing? So now, instead of subtracting a negative, let's add 2. We're going to add 2 here. We're going to add 2 to 5. We're going to add 2 here. And we're going to add 2 here. And now let's simplify this. Tell me what you see. What do you see? What do you see? What's the same? What's similar?
3.
Okay, I see a 3 and a negative 3. Okay, what else do you see? Anything the same? These are the same, right? This is what, actually, if you do it, look at this piece right here. All you have to do is put a bar around this part, and there's your answer right here. So what's the same is the x plus 2. That's what goes in the absolute value. And this is a greater. It's an or in the 3. Now I want you to look at this problem carefully. And I want you to figure out what to do without doing all this stuff. Where do you see this 2, this plus 2 at? Where did it appear? And it's not a coincidence. Where did the plus 2 show up?
It's the absolute value of 2 of the halfway point.
It's that. You know when we said subtract that halfway number? It's that. So that's what goes inside here. Where's the 3?
1 plus 2.
Where did the
Yeah.
3? You got it.
Middle of distance from the middle.
It's the number of units from, this is the halfway number. This is the halfway number. It's the opposite of it. And she's right. These are the number of units, and it's going to be exactly the same. So this is 3 units, this is 3 units, that's the number that goes there. You get this?
So the absolute value of the halfway number goes inside the bracket or the bars, and then
Not the absolute value, the opposite. The opposite of the middle number goes inside here. And then the distance between them,
So it could also be like a negative 2 in there.
it
Like
can
if-
be.
Like if they'll,
Yes,
like if the
yeah,
halfway number
yeah,
was
let's
2.
do this one, you'll see it here. Watch this one. Okay, so, see this? This is what this is. This is a 10, and this is a 16, right? I'm gonna let you see it here. That's the graph of it. Okay, so, what's the halfway number here? What is it? 13. You take the opposite of this number, so it's gonna be x minus 13. Right, look better. Put the bar around here, and then this is gonna be less than or equal to. Now, how many units are you from here to here? You get it? Okay, now this one. This is a negative 4, and this is a 2. Okay, so what's the halfway number? If you don't know how to figure out the halfway number, what you do is you add these 2 numbers and divide by 2. So if you didn't know that 13, add these up, you get 26 and divide by 2. That's how you get the halfway number. So if you added these up and divided by 2, what's the halfway number? Negative 1. So this one's going to be x. Now you're going to subtract the halfway number. So is this going to be a plus 1 or a negative? Plus 1. And it's an or. It's a greater. And how many units is negative 1 away from that?
3.
3. Negative 1 from 2 is 3 units. We might as well do 36 too. What does this thing look like? Well, we got negative 8, and we've got a 20 here. Can you tell me what the halfway number is? It is 6. Everyone got that? 6 is halfway, add these up, divide by 2. So what are you gonna write? X.
Plus v minus 6.
Mm-hmm.
And then on the equal mean is less than 14.
Greater.
You got it. Greater, a greater one is when they go in opposite directions. A less than is in between it. Did you get that? Okay, now, here's a, how much time do we have? Not much. Here's a story problem. Suppose the smallest these are story problems relating to this. Suppose the smallest allowable height of a race car is 50, so they're talking about how tall you have to be a race car driver. So the smallest height you can be is 52. 52 inches. They're saying that the desirable is 52.5, okay? So we want you to be somewhere in between this height. Actually, we're gonna make this, I'm gonna change this and I'm gonna add something. Just to make it easy. I'm gonna say the tallest you could be is 53 inches. That's the tallest. Okay, so let's say the tallest is 53. So the shortest you could be is 52. The tallest you could be is 53. So what would be the halfway number? I think they didn't write, it says the desirable. So we're gonna say the middle is the desirable. Does that make sense? See, to me, that makes more sense. If you say the tallest you could be is 53. Okay, so now can you write an absolute value for this?
X minus 52.5
X minus 52.5 is,
greater.
you got it, you got it. This is 52.5, there's a point there. You get that? 52.5. So in other words, this is the halfway number, and this distance is the same on both sides. Does that make sense? And I want you to, let's see, how much time do we have? I want to try the next one?
Yeah, for
Okay, good, then you guys will do these together, these will be less homework problems you'll have to do. So 69, suppose you use an oven thermometer while baking and discover that the oven temperature varies 5 degrees one way or another. We want our oven to be set at 350. So can you give me the interval, the region, the degree that it could be? We want it set at 350, but it could go 5 degrees either way. Yep, so 355 one way and 345 the other way. Does that make sense? So what's the absolute value? Anyone think they got it? The absolute value of what? X minus 350 is? You got it. Is anyone lost? And the last one. A friend is planning a trip to Alaska. He purchased a coat that is recommended for outdoor temperatures that range from -15 degrees to 45 degrees Fahrenheit. Give me an absolute value inequality for this. Who thinks that they can do this one? Go ahead, what do you do?
Okay, did you call me?
Yeah.
Okay. So you set it up, it's in between, and both of the temperatures count, so it would be the brackets.
Mm-hmm.
And the middle of that would be 15 degrees.
It's 15?
Yeah.
And how'd you get that?
If you combine 45 and -15, it's 30, and then dividing that by 2.
And then divide that by 2. Good job. 15 is the halfway number. That's where she got 15.
And
Okay.
so it would be x minus 15 is less than 30.
Where'd you get 30?
It's the distance between negative 15 and 15.
Yep, these are this is 30, these better be the same number. 30 units. And did you write less than or equal to? Good job. I think you guys got this. Okay, so this weekend, clean up those packets, make sure that you understand everything. Monday, we'll fly through everything and run off the answers, and you guys are good. Have a great weekend. Thank you.